morning children. In the previous class we had started with speed. Now we will do velocity. What was speed? Speed is distance traveled in unit time. Now what is velocity? Velocity is distance traveled per unit time in given direction. That is, we can also write it as speed with direction. Speed with direction is velocity in simple words. So speed with direction also we can say. So velocity, what is the formula? Velocity is equal to displacement, because distance in which direction is there, it is displacement. So displacement by time, which we indicate as V is equal to S by T, where V is velocity, S is displacement, and T is your time. What is the SI unit of speed? SI unit of speed is meter per second, as I had told you. For distance it is meter, and time it is seconds. Similarly for velocity also it is meter per second. Now speed is scalar quantity. In the previous class we had discussed about scalar quantity and vector quantity. So scalar quantity, it has only magnitude. Vector quantity has both direction and magnitude. Now speed, it has only magnitude, so it is scalar quantity. Whereas velocity, it is vector quantity, because it has both speed and because it has both magnitude and direction. Now coming to the next topic, that is acceleration. What is acceleration? You or many of our students, or maximum students, they know that in bike there is something which is called as accelerator. What do you do with accelerator? You just press it and increase the speed. Whenever you accelerator you press to increase the speed of the vehicle. That you know. So it is related to, accelerator is related to speed. The acceleration, word acceleration, is related to your speed. Now what is this? Speed or velocity we can say. So what is acceleration? It is rate of change of velocity in with respect to time. That is, acceleration is rate of change of velocity. Rate of change of velocity with time. See here, important thing. Acceleration is rate of change of velocity. So here important is your change in velocity. Means initially if the vehicle had 10 km per hour speed, now when you press the accelerator, what will happen? It will have the speed of 40 km per hour. So change in speed is there. Now acceleration, we can write it as, okay, I write it. Its formula, acceleration is equal to change in velocity. Change in velocity by time. So it is written in symbolic forms. A is equal to V minus U by T, where A is your acceleration, V is final velocity. The change in velocity, initially it started from 10 km with speed of 10 km per hour. Then when we press the accelerator, it became 40 km per hour. So this is your final velocity and this is your initial velocity. So U, it indicates initial velocity, and there is something which is T, in particular time it is being done. So T indicates your time. Okay, so this is the formula of A, acceleration. A is equal to V minus U by T. This is something which is very important formula. Lot of numericals are there on the basis of this formula. So you need to be perfect with this. Now here you see, what is the SI unit of velocity? Velocity is meter per second divided by SI unit of here meter per second and here divided by seconds. So it becomes your meter per second square. So what is the SI unit of acceleration? SI unit of acceleration is meter per second square. It is also written as meter second raised to the power minus 2, because you have studied in powers and exponents in maths. In powers and exponents you have studied in maths. Meter meter per second square, S is equal to, you can write it as m s raised to the power minus 2. This is for acceleration. Now something which is called as retardation. What is retardation? Retardation is negative acceleration. Retardation is negative acceleration. When the speed is increasing, it is acceleration, and when the speed is decreasing, then it is retardation. It is also called as deceleration. Retardation, that is negative acceleration. The speed here is decreasing, so it is negative and hence it is retardation, or it is also called as deceleration. Okay, now it's the same unit, that is meter per second square for deceleration or acceleration. Only minus sign is there in retardation case, nothing else. Another term is there, uniform acceleration. Now what is uniform acceleration? Now if a body has uniform acceleration if it travels in uniform speed, that is if it travels equal distance in equal time interval. Equal distance, it is uniform motion. What is uniform acceleration? Uniform acceleration, a body has uniform acceleration if it travels in a straight line and velocity increases. Distance increases, motion, uniform motion. Here velocity increases, equal velocity changes. There is change in velocity equally in equal time. There is equal change in velocity in equal time. That is uniform acceleration. Uniform acceleration. Uniform acceleration, a body is said to be in uniform acceleration. Uniform acceleration along a straight line. If it moves along a straight line, if it moves along a straight line where velocity changes equally in equal interval of time. Velocity changes equally in equal time intervals. That is, there is an example, a body when dropped from height, that it is freely falling body. It is an example of uniform acceleration. Here uniform acceleration, what is happening? See, two things are happening. What is changing? Here speed is changing. Speed is changing, and in what time? Equal time. So it means that here in uniform acceleration you need to understand. With another example I'll explain you. It's like this. Like I give you velocity and I give you time. What happened here? Its velocity was 10 meter per second. At what? In 2 seconds. Then 20 meter per second in 4 seconds. 30 meter per second, 6 seconds. 40 meter per second in 8 seconds. See, in every 2 seconds, here how much velocity is increasing or changing? 10 meter per second is changing. Here 10 meter per second, here 10 meter per second, here 10 meter per second. So velocity is changing or increasing equally in equal time intervals, that is 2 seconds. So this is called uniform acceleration. Here the motion is here in uniform acceleration. When it will be non-uniform acceleration? When here suppose it is 10 meter per second, here 20 meter per second, here 45 meter per second, here 80 meter per second. So see here it is 10 meter per second, the change in velocity, here it is 25. So it's not uniform, it's not equal. So when the change in velocity is not equal in equal time intervals, then it is here non-uniform acceleration. Got it? Now, one more thing. Velocity, when it is related to velocity, it depends on two factors. That is speed and direction. When can we say that velocity is changing? If the speed is fixed, still the direction is still velocity can change. How velocity can change? If the direction is changed, then the velocity can change. Even if speed is changing, then the velocity is changing. Even if the speed is not changed, it remains same as it was in the beginning. If in the beginning it was 40 meter per second, now it is in the same 40 meter per second. But initially it was traveling in east direction, now in west direction. So velocity is changing because direction is changing. So velocity, it depends on two things, speed and direction. These things are also related to your acceleration, because acceleration is related to, what is acceleration? Rate of change of velocity. Okay, so I have told you the terms velocity, acceleration, retardation, uniform acceleration and non-uniform acceleration. So I think so you are clear with these terms, and particularly your acceleration is very important because you have numericals with that. SI unit of acceleration is meter per second square. Don't get confused. It is meter per second square. And further we'll do with this chapter in the next class.